This is the second half of page 16, I believe, in your skill notes. It says skill 8 at the top. It's the page where we did the basic exponent rules a long time ago on this side. These should already be in your notes. I'm just reminding you here, we did these. The next page has actual skill 8 on it. And now we're going to go back and pick up more complicated examples of these basic exponent rules when there are coefficients or numbers in front of your bases. So when I look at, I'm multiplying these two terms together, 3x to the negative 2y to the third times 6x to the negative 4y. Again, no exponent. I could stick a little one there for my own sake. My coefficients would be the 3 and the 6. They have no exponents. I am multiplying. I'm going to come down here and break this into little baby problems. It's just saying do 3 times 6. Well, I know 3 times 6 is 18. Those are normal, ordinary numbers. Next thing when I'm multiplying is I can only combine the like terms. So I'm multiplying x to the negative 2 times x to the negative 4. So I'm going to write that as a separate problem. And I know when I multiply two of the same base, my shortcut is to add the exponents. So that is x to the negative 6. Now I can fix that right now, make it 1 over x to the 6. I'm not going to do that yet. You'll see why. Last thing is I have two y's here that I can multiply. So y to the third times y, and I'd already put a 1 there. Again, add your exponents. So that would be y to the 4th. So basically, I had 3 bases inside of each parenthesis, a number, an x, and a y, number, x, y, and I split those into 3 little baby problems. Multiply the normal numbers, add the exponents. So to write the final answer, my normal big number out front was an 18. Well, I had an x to the negative 6, which normally you would write as 1 over x to the 6. But the issue here is I already have an 18, so I don't need the 1. Basically, again, negative exponent means you're dividing by x to the 6 instead of multiplying. So move it to the bottom, it becomes positive, and I only have to put the 1 over when there was nothing else there. This just might be the first time you've had something else there. Y to the 4th is positive, so it stays up with the 18. So bottom line, coefficients are going to stay where they are. They're normal numbers. If your exponent's negative, you're going to move it to the bottom to make it positive. If the exponent's positive, you're going to keep it on the top. And that is simplified. Next one is like this one, where we multiplied exponents. So this problem was like this problem, just big. This one is like this one. So again, look in your parentheses. I see 2 bases. I see a 3 and an x. I'm going to separate this into 2 separate problems then, since there are 2 bases. I have a 3, and I have an x to the 4th. And everything in these parentheses is being raised to x to the 3rd. It's kind of like you're distributing that exponent. So 3 to the 3rd power is not 9 because 3 is a base. It's a big normal number. It's not an exponent. 3 to the 3rd means 3 times 3 times 3, which you don't have to write. I'm just doing it for notes, is 27. Now, x to the 4th to the 3rd, these are exponents where we do our exponent tricks of keeping the base, the x, the same, and multiplying exponents. And then for the final answer, you just smush these together. There's no negative exponents, so nothing needs to move to the bottom. My coefficient is 27, that goes first, x to the 12th. Ta-da. Okay, I'm gonna have to get creative with this one because I'm running out of space. I see 3 bases. I see the 12 and the coefficients. The x's, ooh, take it back. I see 4, the y's, and the z. And I just made a mess doing that, but that's okay. So I'm going to rewrite that as 4 problems. This is obviously a division problem like this one. So we're going to say that's 12 over 16. I'll come back to solve it. The next problem is x to the negative 4 over x to the 3rd. The next one is y to the 5th over y. And the last problem is like, there's no z on the top, there's just a z on the bottom, there's nothing to do with that. So honestly, I'm gonna come over here for the answer. I just know there's gonna be a z on the bottom of my answer, like there's nothing to do with that. So I'm just gonna bring it over now, it's fine. So 12 over 16, we're gonna reduce. You can use your fraction button. 4 goes into 12 and 16, so 3 over 4. We subtract our exponents, top minus bottom. So -4 minus 3 is -7. And we subtract our exponents. We need the little assumed 1 here. So 5 minus 1 is 4. So when I go to write my answer, my coefficient was 3/4, which would look really silly to put it up there. So I'm going to draw a fraction bar here. I already did. And I'm going to put 3/4. X has a negative exponent, so we're moving it to the bottom to make it positive. Y has a positive exponent, so it stays on top. And Z just came over because there was nothing I could do with it. Ta-da. Now, the only thing kind of missing from my examples here that I would like to point out, and we'll have this in tons of classwork, if you end up with a negative coefficient, like if I had -2x to the 5th times 6x to the -8. You don't have to add this one, or you can, I don't care. It's not on your paper. I'm going to multiply the -2 and the 6, and I'm going to multiply the x to the 5th and the x to the -8. These are normal numbers, so -2 times 6 is -12. These are not normal numbers, they're exponents. We add exponents, so x to the -3. Now, when you go to write your answer to this one, you're mushing these two together. This is not an exponent, it's a normal number. You don't move the 12 to the bottom to make it positive. If the coefficient is negative, it just stays negative. So that's -12. X to the -3, that's a negative exponent. You have to move it to the bottom to make it positive, and I don't need a 1 because the -12 is up there. So just an extra quick example because a lot of people get confused by that.